is big converge. Anyways, I
uploaded it anyway.
thing is, you can always convert it later, but not so much.
Have a good class.
Thanks. All right, so today I thought we would start with chapter 4's second exercise, which we haven't had time to see. It's a basic exercise about public good. Because the other exercise that I have for you about public goods is quite out there, in my opinion. It's accidental. I didn't mean it to be that way, but it turned out to be this way. And then we can continue on the midterm sample questions. All right, so let me show. Okay, so this. Okay. This is it. So we have two people. And this is a marginal benefit or marginal willingness to pay. So I could write it MWTP, or here I just wrote it P of Q, because anyways, that's a price. So it's how much she is willing to pay for some public good. Yeah, so if you want to see what's coming before, it's just a public good. All right. Oh, by the way, am I sharing the right screen? Just verify. Yeah. So that's her marginal willingness to pay. That's what she wants. That's what she values. And of course, the thing is, if she only takes herself into consideration when she decides, then of course she's not going to care about other people who might benefit also from the same public good, which in this case would be Bob. Bob's marginal benefit would be this one, 4 minus Q. So you see that Bob likes much more the public good in question than Alice, since Alice's evaluation is 2 minus Q and Bob's is 4 minus Q. And by the way, I've also noted that if they have too much of the good in question, then it doesn't become negative. So if I just write to you this formula, then you would assume that if Q becomes like 10, then the marginal benefit would be 2 minus 10, so minus 8. So that's not the case. It's just that in that case, our willingness to pay for it would be 0. So that's why I said here P equals 0 if Q is larger than 2. So you can verify that if Q is 2, then it would be 2 minus 2, 0. So that makes sense. And Bob's marginal willingness to pay would be 0 if the quantity is larger than 4. So then we have to be careful when we add these things up together. So question A, compute and represent graphically the aggregate marginal willingness to pay. So yeah, so that this is just coming for B here. So just before we do that, let me remind you, in case you forgot about this class, what's up with the public goods. So let's go back a second. Here it is. So we have another Alice and Bob question. So public goods, just remind yourself, is the only instance in which you have to add prices together. Otherwise, you add quantities. Like if it's yeah, marginal aggregate cost, marginal damage, if it's a normal good. So because why? Because people cannot consume what other people consume, so they don't care about, they don't get any benefit from other people's consumption. And when somebody consumes it, then it's not available for them anymore. In this case, it's the opposite. So the quantity available for one, say Alice, is the same that's going to be available for Bob because it's a public good. Plus, what we care about is not just what one person gets from it, but what both person get from it. So then it's essentially it's simpler in this case. If you want to have the aggregate marginal willingness to pay or the aggregate value, you just add these two prices together, or these two individual marginal willingness to pay. And here you see that it's like in the exercise I just gave you. So once it reaches zero, then it just stays at 0. Once it reaches 0 at 3, it stays at 0. So then what happens is between 2 and 3, so Alice's doesn't become negative, it stays at 0. So this segment there is pure Bob. That's only Bob who's going to still benefit, add a bit more benefit from units 2 to 3. And before that, it's the two are added together. So here the marginal willingness to pay for this segment is 2 minus Q plus 3 minus Q. So you get 5 minus 2Q. And here from this segment to this segment, well, it's just Bob, so it's just 3 minus Q. All right, so this is the exercise, the example we've seen in class. Thankfully for you, this example looks very much the same. So please do that. So compute and represent graphically the aggregate marginal willingness to pay of Alice and Bob in this case. Just give you a few minutes to do it, and then I'll do it with you. And yeah, I was unprepared and I didn't do it myself, so hopefully I don't make any mistake. Okay, so let's do it together. So what I'm going to do is copy this, and it will be able to work with it. Oh no, that's the exam. No, sorry, that's not it. But I'm stressed today because my exam is written, so yeah. I just hope I don't show it by accident. Okay, for people at home, let me share this new screen there. All right. This should, how should I do it? Yeah, about like this. Hard thing for me is always to try and plan out how many squares I will need and how I'm going to divide them. So that's 4 and 2. Okay, so for those who have already done the drawing, so what's the biggest number you're going to have there? So that's P. Oh, go away. So what's my biggest number there? Oh, you're right. Oh, gee, I didn't think properly. Should I allocate? Yeah, okay, let's. I was thinking the wrong things. This would be better. 2, 6. Yeah, let's see. This is 2, so this is 6. Oh, it's going to be a nice big one. So, and what's the largest number here? 4, yes. And the other number that I care about is 2. All right, so let's first, so first segment is what? How do I compute it? Somebody has the answer. Yes, 6 minus 2q. So here the total benefit is so between 0 and 2. So everybody benefits from the public good because this is a very small quantity. So of course, everybody has a positive marginal willingness to pay for such a small quantity. So I add up these two together. So I'm going to get, yeah, here I can write it, 6. So by the way, at the exam, I want something from you. So I want either you write the formula or you say this is the marginal willingness to pay of Q. So I know that it's the aggregate one. So I'm not going, I really don't, I'm not the kind of person to just remove points if it's not exactly 100% like I want, but please draw it like you mean to explain to me what this is, right? So I can be lenient, but there has to be some indication. So I like the numbers there, the numbers of the x and the axes. So I know what I'm looking at. So yeah, this is marginal willingness to pay. Or no, I wrote P, so I'm going to stick to the same notation. So P of Q is going to be equal to 6 minus 2Q. All right, so then the question is at 2, where am I? So 6 minus 2Q, that's 2. So I said this would be 2, 4, 6, so I should be there. 6 minus, so I'm looking at what's going to be the value there at 2. So it's 6 minus 2 times 2, so that's 2, yeah. Right, so let's use a nice color here. So again, you're encouraged to note on your vertical axis that you know what this value is. So that helps me in trusting that you understand what you're doing. So and then here, all I have is who's still consuming here. That's Bob. Well, not consuming, but yeah, enjoying the public good. So that's Bob. And then general here it will be equal to could say it's equal to PB of Q, or and you can also write the formula. So that way I know you know what you're doing. Here it's 4 minus Q. And by the way, to know that you haven't made a mistake, what you can do also is compute what is P of Q at 2. And you have to make sure that it's the same as P of Q here at 2. So P of Q here is 6 minus 2 times 2. So that's 2. And here P of Q is 4 minus Q. So that's 2. So we know that we have the right number at this point. Okay, so that was, all right. So that would be worth like 3 points, maybe. I don't know. I haven't put points in it. Okay. So I'm just going to copy the next one. We can continue from there. All right. The marginal cost of providing the public good is MC of Q equals 2Q. So it's an increasing function. It could have been just 2, for instance. Could have given you any function, but be confident I'm going to give you something linear, not quadratic or anything more complicated. Find the optimal provision of public good. So think about it for a while. Then if somebody has something to share about how they would go about it. Okay. Oh, somebody says he cannot hear anything. Try and fix this. Oh, no, it's good. Yeah, can't hear anything because I'm not saying anything, but you don't see that my lips are not moving. So that's why. So somebody has an answer? 4. So that, yeah, that would be other way here. I find this unlikely, possible, but unlikely. A price equal. Yeah, that seems more likely. Yeah. So let's do it. So what's the challenge here? Well, the challenge is to know whether you have to care about this segment there or that one. So there's, yeah, you could, a good way to do it would just be to estimate marginal cost of 2 and see whether it's below 2 or above 2. So it gives you a good idea if it's on the left or the right. So it's, if your graph is nice, then just draw it and it gives you a pretty good idea what's going on. So here, yeah, here we have 2 like this. And so at 1, we would get, so this would be 1, so we would get 2. So it would look like this, I think, possibly. Yeah. So it might be even better if really your scale is exactly the same, then you have no chance of messing up. Here, so this is 1. So marginal cost of 1 is 2 times 1, 2. So yeah, that's all right. So then we have a quite good idea that the price is, yeah, I can just see it visually that this should be 3. So nice, nice suggestion. I think it's, but let's just compute it to be sure. So this is B. So what we do is MC of Q equals to 6 minus 2Q. Yeah, so just equals P of Q. This is oh, so maybe I'm wrong in some way in my drawing. Yeah, this I get 4Q. 4Q equals 6. So Q equals, oh yeah, no, it seems good. Then I get Q equals 6 divided by 4, so that's 1.5. So you can write QS maybe for social optimum, social optima. If I don't say note this way, then yeah, you note it in a way that makes it clear that yeah, that's the social optimum. And let's compute the price. So P of 1.5 would be equal to 2 times 1.5 equals 3. Yeah, so that looks like so so I don't have a great taste about do I want fractions or do I want numbers with decimal points. As long as it makes my life easy or the life of the T is going to grade it. All right, so that would be B. Questions about this? No. So again, to know whether you have to use this segment or that segment, just compute a marginal cost of 2. You would get that this would be 4. So then you know that, oh, it's probably I went too far. So the answer would be on that side. So then you know that you use this segment. All right, so that was B. C. If the marginal costs were if Q equals Q over 2, how would would the answer change? let's write it. Oh, and yeah, something I should have done is so people at home, I know it's you're comfortable in your own house, but you can try and compute stuff too. Feed us some answers. Somebody has an answer? I'll give you a few minutes. Yeah, so about the calculators, you can bring one because I know it's if you have it, you feel safe and secure and protected by the gods. So yeah, I want you to have this nice and warm feeling. But as you can see, you're probably not going to use it all that much, but who knows? Yeah. 2.4. That's a strange number, but yeah, it's possible. So on which segment am I? This one or that one? So this is the combined one. Yeah. All right. Okay. Not sure I believe you there. So what's your answer again? You said it's the quantity is 2.4. So 2.4 is, yeah. So then if it's 2.4, so you're on that. This is 2. This is 4. So 2. This is 3. So you are about like this. So if you use that one, so it might not be exactly the right. So I didn't want necessarily to tell you about this, but there's another way to do it to know on which segment you are. So you just compute your solution with the first segment, compute your solution with the second segment, and then you check whether your solution is on that side or that side. If you use this segment and you find that your solution is like here, well, you know it doesn't make sense because you're farther away and that thing doesn't exist here. So, and same idea, if you use this segment and you find that the optimal quantity is like here, well, you know it can't be so what we would have done is essentially prolonged, make this longer on that side, but that's not appropriate. So so it's like trial and error. So you try with one and you see whether you land here or here. You try with the other, you see whether you like here, here or here. But I don't know. I feel it's a bit more complicated than it needs to. So just compute it here. So let me show you how I would do it. So let's figure out on on which segment we are. And so left of, yeah, so let's just compute marginal cost of 2, and this of course is the new marginal cost, would be equal to 2 divided by 2, so it's equal to 1. All right, so, and I can just draw it. So this is 2, so 1 is like this. So this is my second one. And 1 is there, right? At 2, and this is equal to 1. All right, so I can pretty much know that I won't be on that side. I will be on that side because the intersection will be with the second one there. So 1 is smaller than 2. So intersection. So solution is marginal cost. Here that would be 2 divided by 2 equals to, here I have this segment there, formulas. So I find that. Let's multiply everything by 2, so I get Q8 minus 2Q. So I get 3Q equals 8, so Q equals 8 divided by 3. So, oh, that's a nasty number. Let's leave it that way. And yeah, I can see that I didn't set it up very nicely because I indeed did something very weird. Yeah, so these kind of numbers happen. And the price will be divided by 2. Just want to not confuse anybody, so we get 8 divided by 6. Or 4 divided by 3. Does that look like it makes sense? So my 4 is there. So if I divide it by, yeah, it makes sense. Graphically, it makes sense. So that's always something I like doing, is just looking at where this lands on the axes, and yeah, does it look like it can be the case? So yeah, if I multiply this by 3, I could get something like 8 there. So my answer, it makes sense. If I had gotten something like, I don't know, 20 divided by 3, then you know that it's up there, so you know that this can't be the case, so you made a mistake. So just drawing your things well is very helpful to make sure you didn't mess up. Is that all? Yeah, that's all for that. Also, yeah, conclusion. Yeah, I didn't conclude anything. So what's the moral of the story? Moral of the story. If the marginal cost is smaller, so 2 divided by 2 instead of 2q, then it's efficient to provide public. I could add, let me add some quote unquote trick questions. So question at q equals 8/3, so that's my second one. What is the marginal minus to pay of Alice? Yeah. Yes, but look at. Oh, if yeah. Okay, it's fine. Yes, so look at this here. So it's of course you get a negative number. So that's why I said no. She would like less of the public good. She would just not enjoy any more than that. So yeah, it's 0. So if for q equals is larger than 2, and yes. 8 divided by 4 would be exactly 2, so 8 divided by 3 is larger than 2. So it is greater than 2, so all right. So this is a very basic, but at some point I'm not going to ask you super involved questions during the exam since you're learning. But yeah, it's a good example of the kind of thing. Question about this? All good. All right. Well, if you have any, just email me. And well, I have office hours tomorrow at 10:30 about in my office. So if you need help for anything, feel free to just knock on the door. Okay, so this is a neat one. I hope I don't lose it. Now let's have crazier questions. If you're ready for crazy questions, you're going to be ready for not crazy ones. So yeah, that one. So that one is the crazy one. So 2 is I don't know. So that one is just like the one we just did, but more complicated. So let's go with that. So I'm going to share the screen. Okay, so that's number 2. two factories are located close to the St. Lawrence River. Their emissions cause environmental damage. The cost of abatement for factory A is given by MAC A of EA is 200 minus 0.1 EA. And for factory B, it's MAC B equals 200 minus 0.4 EB. The damages caused in the river are given by marginal damage of E equals 0.12. Find how many units of emissions the two factories will emit if they are left unregulated. So this, I think we did that last time, so should be a bit better. Somebody knows? Yeah, it makes sense. Yeah, so the trick here is just 2000 minus 200 minus 0.1, 200 divided by 0.1 is 2000, and 200 divided by 0.4 is 5000. But let me just show you again that this is the case. So of course they emit until MPC equals 0. So from A I have 200 minus 0. A equals 0. So that means that 0.1 E equals 200. So divided by 0.1, I can get E equals Oh, sorry, yeah, I forgot to share my screen. So that's for firm 1. Firm 2 is 200 minus 0.4 ED 0. ED is 200 divided. That's so that's, yeah, 400 times less than 2000. So that's 5. All right, so that's A. So yeah, so this you can do it very quickly if you. It's possible I ask you a similar question. So and this is a good start to it, just to put you in a good mood and feel confident about your ability to answer a question, because it's not a too difficult one. All right. Oh, I even put points there. All right. Derive algebraically and graphically the agreed marginal abatement curve, cost curve. That's possible. I'm going to ask you something like this too. So so just get the feeling is, does this look like it's simpler or more complicated than usual? Simpler or more complicated? The same? Yeah. Yeah, there is something different about this one compared to the previous ones, which should make it simpler. And tell me what it is. Yeah. No, that's, well, you may not actually, but yeah, I would encourage you to do it anyways. But yeah, I'm going to tell you what's easy about it by just drawing them actually. So let's draw these two things. So 200 minus 0.1 A and 200 minus 0.4. So I have to get to 2000 for one, so that's going to be 2000. And the other is going to be so yeah, no, that's not okay. So this is 200. So this is 20. Maybe. So where am I going there? I'm going to 2000. Here I'm going to 500. This. So can somebody tell me what's easier about this one than usual? Here, I haven't done anything. I just plotted these two things. Somebody at home, please help us. Now I'm not too happy with your performance. Haven't gotten any good answer from you yet. Yeah. Um, yeah, I don't think so. Some other suggestion? Yeah. Yeah, that sounds not bad. So I'm going to tell you. So what's easier? So normally I have, say, one firm that starts here at 400 and the other that starts at 200 or 200 and 100 or something. And then what do I get? I get a kink. So I get, because what I care about is whether this firm starts at the same point or at that firm or at a different point. So here in this example, I was nice by giving you the exact same intercept. So you don't really have to care all that much about do you have a kink or not. You don't have one. So as I said, so it's not a 400 minus something because that would be adding the prices. Price. This is a quantity. Yeah, so anytime it's not a public good like the last exercise, you add them up horizontal. Because here what we're applying is the equimarginal principle, which says that I'm going to try to minimize my marginal abatement cost whenever I can. So I'm going to ask myself something like, imagine I want the abatement cost to be not higher than 100, for instance. How much would I have been able to abate in total? Well, I could have asked the first firm to abate 2000 minus, so this would be 1000, so 1000. And then the second firm would have abated like 250 maybe. So then the total abatement here would have been 1000 plus 250, so 1250. So, and if I want the aggregate curve, so I want the value that the total emissions abated at every possible price value. So the how I must do it is add up the quantities. So yes, we do need to invert the curves. But what's nice here is both starts at 200. So there's no, I'm not saying that's going to be like this at the exam, but so be ready for the worst. But let's do it. So here I'm going to draw. I don't know if I can get, yeah, that would be like very far there, but yeah, no, let's give ourselves. Yeah, so here it starts at 200 again, because above a price of 200, all firms have abated everything, so I don't have to care. So it starts at 200. And then what is the total emission if I don't ask firms to abate whatsoever? It is 2,000. Yeah, 2,500. Yeah, firm A is going to emit 2,000 and firm B 500. So the total. So that would be yeah, MAC. Or and how do I do it? Well, I invert my thing. There. So if you can, if since we have the this and this, it's very easy to just look at it visually. But if I want to show you to do it always the same way, so you don't mess up, so let's do it. So inverting the two. AC is 200, and so I get that. So let's multiply by 10. So I get 2,000 minus 10. And yeah, so I get that thing. Sorry about this. That's in the way. So let's multiply by, divide by 0.4. So what do I get here? Somebody do this on their calculator. So that's times 10 divided by 4. So that's, yeah, so that's 500. And this is 10 divided by. Okay, so now adding the two together, So I so that's 2,500 minus that's 40 divided by 4 and plus 10, so 50 divided by times. Oh yeah, so then you can just all right. I think I didn't miss. And then inverting back. So I multiply everything by 4 and divide by 50. So let's start by dividing this by 50. So by 10, this. So by 5, that's this. 10 times 4, I get 200, which makes sense because that's what I want here. Okay, so it looks like I'm on the right track, and then minus 4. So what's 4 divided by 50? That's somebody can do it on there. Yeah, 0 point. Okay, fine. I put all my faith into your calculator. Okay, so that would be it. So you can see that now you found that it's the function of t. So of course, another way of doing it would be, yeah, just saying, I won't judge you whether you find it in one way or the other. Just show me that you didn't. It just didn't just pop up in your head, so you can say, "Oh, I did it this way or that way." So another way of doing it. So you could say, I see here that this should start at 200. So I should have something like MAC of E equals to 200 minus X times T. And I don't know what X is, but I know that when E equals 200, 2,500, this should be 0. So let's find X. So I know that sorry, 0. So then that X equals and that should equal the same thing, right? So Am I dreaming, or is that the same thing? Yeah. I think it is. So then you know what. So that way is fine too. It's actually faster than that way. So it helps that if you know the intercept and the intercept, then it's quite easy to do. Next question. All right. So question about this before we move on, or I'll let you copy. Find the socially efficient level of emission. Show the equilibrium on your graph. So here, that's easy. You just have one segment, so you know what to do. Just to remind you, the marginal damage is 0.12 times E. Suggestions? Let's find out. Yeah, so you find that the marginal abatement cost equals marginal damage. So when I just said it's 0.12, right? I think. I get point, so 12 plus 6. Equals to 1. Yes, for social. And am I at the bottom of my page? Yes. So then just substitute it in one or the other. So MDF 1000 equals to 0. So it's equal to 120. So where does that? So this should be at, okay, a nice trick is, I know that I'm looking for, yeah, so this 1000 should be somewhere like here, I think, or yeah, somewhere. So that should look like this. Yeah, since I didn't start in a nice corner, it's not easy to see visually, but I think it's more or less feels okay. 100 is like here, so 120 is there. Yeah, feels about. So that would be it. Thank you. Nice answer. And 5 minutes left. I think there might be. Oh no, there is. Oh no, that's the previous one. Oh yeah, that's let's yeah, let's do that. I think it's very useful to do it. Calculate the total social cost at the socially efficient level of emissions. Show the corresponding area on your graph. So I'm going to, yeah, do it here. Total social cost. Do your best. So it's at the socially efficient level. So at 1,000, what would be the total social cost? Well, just before we start, somebody remembers what it is? So if you're calculating stuff, it means you know what you have to do. So please tell me. No clue. Oh, not to Pablo, to everybody. Yeah, it would be the area. Nice one. Yes. Oh, okay. So what did you do? Hmm, so that would be the total abatement cost if we abated entirely emissions, right? But here I was asking what is the total social cost? So if we abate 1,000. Yes, so which base and which height? Okay, so we have a number to work with. So let's see. Let's see. Somebody else had something different. Yeah. So that would be this thing, right? So this is what is this? That's the total damage. And what is this? It's the total abatement cost. Total abatement cost is how much in total did I pay to abate all these emissions, all these units. Total damage is how much damage is going to still be allowed to go in the environment. So I'm going to have 1,000 units of emissions. Oh yeah, I put Q, but I think I should put E there. Sorry about this. And the total social cost is TD plus TEC. So it's the fact that firms have to pay to reduce their emissions, but still the society has to suffer some environmental damage. So it's the both of them. total damage at 1000. Plus total abatement cost at 1000. Yeah, so this is just, you have to sort of remember how you compute these things. So what we mean by total social cost. Yeah. All right. So let's try that. So if I ask you to compute individually the total damage or the total abatement cost, you would compute this triangle and then that triangle. But note that here I just said, please give me the total social cost. Well, this is a triangle. So let's just compute the whole triangle. So equal to 200 and 2,500 times, and here I have 120 divided by 2. So here, yeah, for that you need your calculator. No other way. So please bring your calculator. Oh, no internet. Windows is no help for me today. Yeah, so somebody can compute this. Yes, nice. So yeah, I think that's what you had. So here it is. All right, so thanks a lot. And yeah, any more questions? I have office hours tomorrow. I'm going to answer you during, I don't know, I'll try maybe during the weekend, but if please try and send your questions before that if you have any. And I'll post all of these solutions. So, and the solution to the last question we didn't have time to do. And yeah, best of luck to you all. So, no, there are no assignments. So it's after the exam, I'm going to see what the assignment is.